In this tutorial, we will go through all the sleep modes of DA14592. But before we begin, let's take a look at the DA1459 family. Now let's understand the 4 power modes for DA14592 SoC. First, the hibernation mode. This is the lowest power state, ideal for shipping, where all RAM and clocks are off. Only the always-on power domain stays powered. The device can only wake via a reset or a trigger through specific GPIOs. Next, the deep sleep mode. This is like hibernation but with RTC support. RAM is still off but the RCX oscillator runs, enabling time-based wake-ups like alarms or watchdog resets. Then comes the extended sleep mode. It is used during Bluetooth connection, retains selective RAM, and keeps the RCX running. All the domains are off except always on power. Its wake-up sources include timers and GPIOs. And then finally we have the active mode. Here the system is fully awake, either running at low power or high performance levels, depending on the use case, and flash access is enabled. We will now review an example to illustrate the usage of deep sleep and hibernation modes. It's an example from Renaissance from BLE SDK examples. We can download and import that in eSecure Studio. The purpose of this sample code is to demonstrate the sources that can wake up the device from deeper sleep states and the concepts of alarm events from RTC controller and power on reset through GPIOs are exhibited. So let's go through the source code now. This folder contains main application code including the initialization routines, sleep mode configuration, and CLI implementation for runtime control. So the CLI application is here. The CLI app uses the UART2 peripheral for serial communication, allowing us to interact with the device via a command line interface. Here all modes are enabled by default. The CLI module allows us to configure sleep modes and wake up sources at runtime. For example, we can send commands over the UART interface to enter the hibernation mode, configure the RTC alarm, set the GPIO wake up interrupts, and configure wake up sources. So from the sleep modes, first we have deep sleep mode. Here it defines the functions to view its status and get the information related to deep sleep mode. We can set the status here to enable or disable. Here it allows users to configure GPIO pins as wake-up sources. And the reset function removes the pin as a wake-up source. And here is the initialization of the deep sleep mode. Then we have hibernation mode. Here we get the status of hibernation mode. And here we can set the status to enable or disable. And then we have the select port function to configure GPIO ports 0 or 1 with its pins 14 and 4 as wake-up sources for hibernation code. Then we have power on reset functionality. It allows users to configure a specific GPIO pin as the source for triggering a power on reset. And it configures the GPIO port, pin, and polarity for power on reset from this function. And then it sets a timeout for the power on reset event. Lastly, we have real-time clock controller functionality. This code sets and retrieves the current RTC time and calendar. So this function CLI RTC alarm set sets the alarm. And then we have CLI RTC PTC entry add function, which registers RTC events with the power domain controller to notify the main core when the RTC events occur. And finally, the RTC events such as alarms, interrupts are handled using a callback function. And finally, this is the main task file, which registers the CLI handlers here, and then sets the device sleep mode according to the configuration enabled. So here it enables the RTC functionality, and then for hibernation mode, and then load the application on the chip. So now the application is running on the SoC. Now to observe the power consumption for various sleep modes, we will utilize the power measurement module on the SoC. For this, we need to download the power profiler provided by Renesas, which is Smart Snippets Toolbox. We can download it depending on our operating system from here. So I'm using Windows, so I will download this one. And once the downloading is completed, we can install it. Now open the Power Profiler tool and attach the BLE chip to the PC. And before we start the measurement, we will first perform some calibrations. So as the first setting, select the device from the drop-down menu. We will select this device. So the device is selected. Now enable Power Profiler and now select Config. Set the sample weight to 128K samples. And now by selecting offset calibration, the calibration session will start. And here we can see the average current. By default, the application we are using uses the extended deep sleep mode. So this is the power measurement for extended deep sleep mode. We can set the time interval to 5 seconds. Now moving forward, we will change this mode. So we will select the other COM port that is attached to the SoC and set the baud rate. From terminal, enable local echo. And now from the commands that we saw earlier, we can check the status. So here the deep sleep mode is off and we can enable it. Now I have entered the command, and now to desert the serial console, we will close this terminal. And now we will initialize it to see the average current in deep sleep mode. So this is the average current consumed in the deep sleep mode. Now again we will change the mode to hibernation. Now we have set the hibernation mode to enable. And deep sleep mode to disable. Now again close the console. And now again we can start the session. And this is the average current that we can see in hibernation mode. Like this, we have observed the power measurement in all three sleep modes, which were extended sleep mode, deep sleep mode, and the hibernation mode. So that's it for tutorial, and see you in the next one.